Hi everybody! For this video we're gonna look at measuring some circles. So I got my measuring tape, I got my circle, and I'm gonna show you how you can measure your own circle at home. If you don't have a measuring tape, that's okay. You can use a piece of string, and then when you're done measuring, just hold the piece of string up to your ruler and it's the same thing. All right, so here we go. I'm gonna start with my pie pan. And I'm going to measure all the way across the pie pan, back of the pie pan, to get the diameter of the pie pan. Now if you look, it looks to me like the diameter of the pie pan is pretty much exactly on the 9 inches there. And notice how at the other end of the picture, I don't start with the 1, right? I start at the little metal tip, that's 0. So you want to start measuring at 0 and you go all the way across the circle. Okay, so that's the diameter. So remember our diameter this time is 9. You're going to try getting your own diameter at home, right? Now I'm going to do the circumference, which is all the way around the outside of the circle. So I got to wrap the measuring tape or string around the circle until I meet where I started. And if you look here, it looks to me like I'm back at 1 again. The 1 matches up with about, whoopsie, the 1 matches up with about 28, not 29, looks like 28, and I think that's 3/4, 28 3/4. Now, you're going to say, how did she get 3/4 that fast? Those sort of in-between size, the largest mark in the middle is a half. The next size of mark is a 1/4. So I think that's 1, 2, 3/4. But the other way to do this is to say, okay, between the 28 and 29, how many little tiny little tick marks are there? And if you count them, so don't count the 28 itself, but count every little tick mark after that. And I counted already. There are 16 of them. So if there are 16 little tick marks, and when I'm right there where my fingernail is, that's 12 little tick marks. So I have 12/16. If you take 12/16 and you reduce it, you will find that you have 3/4. But you might have to do it that way in order to be absolutely sure. So now remember our two numbers. We've got 9 for the diameter and we've got 28 3/4 for the circumference all the way around the circle. And now we're going to use the calculator and see what decimal that gives us. So now let's go to the calculator. And we have 28 3/4. You might not know what fraction, what decimal that fraction is, right? So what you would do is 3 divided by 4 to get yourself the decimal, and that's 0.75. Or if you hadn't reduced your 12/16, you do 12 divided by 16, and that's also 0.75, plus the 28. So 28.75, that was my circumference. And I want you to do circumference divided by diameter. So in my case, that's my number. Look at what I got, 3.19. Now 3.19 is pretty darn close to the number I was looking for, which is pi, 3.14. Now, no matter what size circle you have at home, when you do your division, you should get something that's close to 3.14. So when you divide the circumference of a circle by the diameter, you should get pi, which is written like this symbol, or written pi. And that's why I have my pi plate here in honor of pi. You can use this fact, so this is the fact that you start with, that c divided by d is always giving you pi, to get the formula for the circumference of a circle, which is c equals pi times diameter, or c equals 2 pi r. And both of those are gotten from pi. So we didn't start with the formula for the circumference of a circle. We started with the discovery that when we divide these two numbers, we're always getting this number pi. And so I just wanted to share a few of these poems with you that have to do with pi. And I want you to see if you can tell what they have to do with pi. So this is an English one. It sounds like it's from the 1950s, right? This one sounds like it's from much earlier than that, and it's my favorite of the poems. Sir, I tell a rhyme excelling in sacred truth and rigid spelling. Numerical sprites elucidate, for me the lexicon's dull weight. And the Spanish one is also very beautiful if you can read Spanish, and the translation is here. What do all these three poems have in common? Look at the first word in each. This is how, this is sir, this is fue. They all have three letters. And then the next is one, and then the next is 4. These are the digits of pi. 3.141, this is 5, 9. And so these poems were written to help people remember the digits of pi. The French one would help you remember 126 decimal places if you could remember the whole poem. In the Chinese version, the numbers are actually translated into characters that sound close to that number, and so it makes a different kind of poem. And a lot of schools will celebrate Pi Day, which is on March 14th, 314, which is like the digits of pi, 3.14. And there's some great ideas of ways to celebrate Pi Day. Now, I want to end with the idea of rational versus irrational number and how that relates to pi. Irrational means not a ratio, not rational, not a fraction. So this 0.5, since it can be written as a fraction, is rational. It's 1/2. 0 is also rational because it can be written as 0/2. You can write negative numbers as fractions, but pi, the one we just got, cannot be written as a fraction. When I was in school, we were told that 22/7 is the fraction for pi, but it quickly goes off there. We were supposed to use it as an approximation, but because we didn't have calculators. But it's really bad to tell kids that pi is that fraction. Pi does not equal any fraction of two whole numbers, ever, because it is irrational. So you can tell a number is irrational if the decimals in it go on forever and ever without a repeating pattern. If you look at this has a repeating pattern. So we know we can write it as a fraction using the trick I showed you in the previous video. But pi, 3.14159, etc., doesn't have a repeating pattern. So it cannot be written as a fraction. In addition, square roots of numbers that are not exact. So, for example, the square root of 2, that number right there, if you put that in your calculator, you also get a never-ending decimal that doesn't have one repeating pattern. So that's irrational. Irrational, not rational. So in your homework, I ask you to tell me whether number is rational or irrational, being able to explain why it's rational or irrational. Have fun measuring your circles. See you in the next video.